This video is a compilation of all the philosophy TikToks that I made in 2021. Pretty much all of them are standalone, so if there's a timestamp that takes your fancy, feel free to jump straight to it. If you have any questions about any of them, feel free to put them in the comments below. I live for this stuff, and I hope you enjoy them. Here's a thought experiment. You need to go across deep space, and you have two methods of travel available to you. The first is a kind of teleporter. The way it works is when you walk in, it'll scan the positions of every single atom and molecule in your body, and then it'll disintegrate you. But it'll broadcast the scan of your body to a teleporter on the other side of the galaxy, whereby using atoms and molecules over there, they'll reconstruct you perfectly. This has a 100% chance of working. Option 2 is to go by spacecraft. Now, because spacecraft are kind of an outdated technology, this only has a 50% chance of working, and the other 50% chance is, well, you don't make it. Now, you want to take the option that's going to maximize your chance of survival. Which do you take, and why? Here's an uncomfortable idea. Science can't actually prove theories, it can only hope to disprove them. This might sound ridiculous because we hear things like scientifically proven all the time, but here's an example. Suppose you were trying to prove the statement, all swans are white. In order to do that, you would need to find every swan that ever existed throughout all of time and space and check whether it was white or not. But in order to disprove it, you would need to only find one black swan. Proving something wrong is infinitely easier than proving something right. This is something that was observed by the philosopher of science Karl Popper, who said that there is an epistemic asymmetry between proof and disproof. What a phrase. We can't prove our laws of physics hold true for every time and place in the universe because we don't have access to every time and place in the universe. We can't check every electron is the same. We can't check that the same nuclear processes power every star. Popper argued that basically the way we should decide our scientific beliefs is through a sort of survival of the fittest process by running competing theories through experiments. Whichever theory's predictions don't match the experimental results basically get killed off, and eventually we'll be left with one theory. We won't know that theory is right, but we'll know it's less wrong than the other ones, and it's only logical to go with the one that survived. If science can only disprove things, then how are we meant to deal with ideas like this? If we're only going to go with a theory that hasn't been disproven yet, aren't there like a lot of theories that haven't been disproven? How can we possibly choose? Popper did consider this, and he tried to put together a very complete philosophy of science. How to distinguish between scientific ideas and knowledge that we should take seriously from other kinds of ideas was called the demarcation problem. And Popper's answer to this was falsification. We should only take ideas and theories seriously that we would know how to falsify in principle, if not in practice. Interestingly enough, Karl Popper came up with these ideas in part because he was watching lots of psychoanalysts with their patients, and he recognized that irrespective of the patient's behavior or feelings, the psychoanalyst could fit their theories, often Freudian theories, into explaining what was going on. He was very frustrated by this because he said, if I give you a patient that does the complete opposite of what you said the last patient would do, you'll just come up with another reason. Your ideas are unfalsifiable and therefore aren't scientific. Space ones may exist somewhere in the universe, but because we have no idea how we'd even go about trying to disprove that idea, according to Karl Popper, we shouldn't be taking it too seriously right now. I'm about to explain a problem to you that's at the root of all science. Most philosophers consider this unsolved and believe that perhaps it'll never be solved. It's called the problem of induction. There are many kinds of reasoning, but two main ones are called deductive and inductive reasoning. Deductive reasoning is associated with Sherlock Holmes. We like deductive reasoning because the conclusion always has to follow if the premises are true. Here's an example. All men are mortal. Socrates is a man. Therefore, Socrates is mortal. Basic hard logic works every time. Inductive reasoning, though, is a bit weaker. An example might be, I've met this person a few times and they've been nice to me every time, therefore I believe that they're a nice person. Or more formally, I see B follow A every time, so I believe that B, as a law, has to always follow A. Now, as I'm sure we all know from our own personal experience, inductive reasoning doesn't guarantee its conclusions. Just because you see a pattern doesn't mean it's going to be repeated forever. It doesn't mean it's a law. The problem is, all of our scientific knowledge, all of our laws of nature, seem to be based on inductive reasoning. Our laws of gravity, electromagnetism, light, all work for the patterns we've seen previously. But they all rely on the assumption that that pattern's going to continue. You might be thinking, no, these are laws, that's different from like a pattern. But how do we know? We haven't seen these laws in a law book. We've just invented them to explain the evidence that we've seen so far. And if the history of science has taught us anything, a new discovery can cause us to rewrite the textbooks about everything at any time. This idea really starts to mess with you if you start to think about it, because humans very naturally use inductive reasoning. Think about the way you learned not to touch a hot pan or trip over. It was from having an experience, associating it with a negative outcome, and then assuming that that pattern would repeat if you did it again, so you just didn't do it. And the reverse is true. We do most things because we've had a positive experience beforehand and we expect that will be repeated. Human instinct is fundamentally inductive, and inductive logic doesn't guarantee the outcome. So if induction is at the heart of all science, how can we have faith that science is going to work tomorrow? Most scientists and philosophers, when they hear this problem, despair a little bit and basically say that you have to assume on some level that the universe is going to hold to certain patterns, that the past in some way will resemble the future. But there was one philosopher who thought they found a solution. More on that next time. Solving the problem of induction. If all of science seems to use inductive logic, i.e. the idea that the future's going to resemble the past, or that if we see a pattern in nature, we expect it to repeat. If it's based on this logic, which clearly doesn't always hold true, then how can we trust scientific predictions? Isn't this like a fatal flaw for science? Karl Popper claimed he had a solution. He said, look, inductive logic is problematic, but it's not a problem for scientists because science doesn't use induction. If science was just inductive, then we would never be able to make a prediction for something we hadn't observed before. But we do this all the time. There are so many instances of this in the history of science. As an example, black holes. These were predicted by Karl Schwarzschild. He did this using Einstein's theory of general relativity. Einstein came up with this elaborate, principled explanation for how gravity in the universe works. And from those principles, we derived unexpected consequences that predicted phenomena which only afterwards we observed. Clearly that's not an inductive process. Another example is the prediction of antimatter from Paul Dirac. He basically looked at an equation he came up with and went, you know, if we flipped all the signs on this, the equation would still work. And after that, what do you know, we discovered antimatter. Instead, science uses conjecture and criticism. We can't hope to prove a theory true with past evidence, because there's always a chance that we'll find future evidence that proves us wrong. He said we can only seek to falsify, prove wrong, certain ideas we have at the time, and follow the ideas which are not falsified, as in the ones we know aren't wrong, that might be right. All we can do is use our best theories at the time. The thing is, most philosophers don't actually buy Popper's argument for a number of reasons. It just doesn't seem to be the way science actually works. Normally we trust ideas that have evidence, and we often have to make decisions between two competing ideas or theories which haven't been disproven yet. If we can't use induction, and past experiments haven't falsified any of the hypotheses that we're looking at, then we're kind of in a bind. Popper did try and get around this by saying, oh no, we should trust theories that have been heavily tested, they've been corroborated. But that kind of just seems like an induction in disguise, because if they've been heavily tested, there's lots of evidence for them. David Deutsch takes a different approach, and he says we should trust ideas which have better explanations. But that opens up a whole different can of worms by asking, well, what makes for a good explanation, and all of that. The great scientist Galileo once said words to the effect of, mathematics is the language in which God wrote the universe. Now, putting God to one side for one moment, it does seem to be the case that our explanations, our theories, are much deeper than simple seeing a pattern and hoping it repeats. At the end of the day, regardless of what logic you use to justify your scientific predictions, I think the problem of induction sort of shows us that, as much as we'd like there to be, there is no absolute certainty in science. And while yes, it does seem to be the case that the universe is written in the language of mathematics, that's only been the case so far. And hoping that it holds true for the future is just another inductive argument. There always might be another discovery around the corner, ready to shake things up, or the laws of physics themselves may change one day. But I think realizing this and coming to terms with it is really quite cool, because amidst all this uncertainty, we have clearly made progress in how we understand and operate within the universe, from the ground layers of philosophy to the modern day experimental process. Ah yes, the metaphysics of time. Now we're getting to the good stuff. Firstly, what is metaphysics? Metaphysics is kind of the academic branch of philosophy, which is kind of like stoner thoughts, minus the drugs. Asking questions like, but what is time? More formally, metaphysics is the abstract branch of philosophy which concerns itself with things like identity, space, time. A lot of it tries to bridge our understanding between how we see the universe in a scientific context and how we see it in our subjective context. So an example of that might be Theseus's ship, whereby, you know, we might replace all the parts of a ship over the course of some time, and so from a sort of physics perspective, you know, it's made of different materials, it's not the same ship, but to us there's some sort of preserved identity within the ship. That's kind of like a metaphysical question. The metaphysics of time is really interesting because it says, look, there are some other things about the nature of time which don't seem to be covered by modern day physics. One of the key debates in the metaphysics of time is the idea of whether there's a present moment or not. Obviously, all of us experience a sense of sort of time passing, of us moving through our days, but there's no real description of any sort of present moment in physics. In Einstein's relativity, time is just another dimension. There's no sense of it passing or moving. Interestingly enough, there are three broad theories on this, called the A, B, and C theories respectively. A theorists believe that there is an objective present moment which moves continually forwards in time that we experience. One version of this view is called the spotlight theory, which basically says, look, all moments in time are equally real, but only some of them are available to us, evidently. The ones that are available to us are called the present moment. That's now, and that moves like a spotlight along a timeline. People who believe in the B theory of time disagree. They say, no, that's ridiculous, there's no such thing as a present moment, it doesn't make any sense in physics, there's just a sequence of moments. However, they have one unique direction. Time in a certain sense is kind of like a movie. You've got a selection of sort of frames of moments, and they're meant to be played in one particular direction. So, you know, we can say that the Eiffel Tower was built after the pyramids. That's fine, that's true, we're all happy. And then you have the C theorists of time who say, we can't even say that time has a direction. There's no present and there's no inherent direction to time. All we can say is that there was some time that separated the building of the Eiffel Tower and the pyramids. We can't technically say one happened before the other because our perceiving of time having a direction is probably a complete illusion. Obviously, there's lots of nuance to each of these. This is a very brief overview. They all raise really interesting problems and provide solutions to other questions, and if you're interested, I'll happily talk more about them. I mean, the force just gets transferred through the object. Object doesn't move, force doesn't stop. You are trapped inside a paradigm. We'd like to think that science is a process which is rational, perhaps even objective. We make hypotheses and then we test them. But then along came a man who disagreed. The man was a triple threat, a physicist, a historian, and a philosopher of science. And he said, yes, it's great we all have these strong ideas about how science should work, but if we actually look at the past, if we actually look at the evidence, we'll come to a very different conclusion. The man was Thomas Kuhn, and in his groundbreaking work, The Structure of Scientific Revolutions, he argued that most scientific practice, most normal science, all operates within a paradigm. A paradigm is an overarching idea or explanatory framework which answers some questions and asks others. It is the lens through which scientists, and yourself, view the world. But it's even more insidious than that. Your paradigm doesn't just tell you what's true and what's false, it tells you what questions are even worth considering in the first place. Kuhn pointed out that most normal science does anything but question the underlying assumptions of existing paradigms. Instead, most experimental results which are published agree with theories, they just add detail to them. Anything anomalous is just, well, it's just that, isn't it? It's anomalous. A dud result or a failed experiment. Even to this day, we tend not to publish null results. This is obviously the complete opposite about noble ideas we might have about science trying to disprove theories. But it gets even worse. I'm sure you've met people who have very different beliefs or different paradigms about the world than you do. You might read the same article or watch the same video, but you'll arrive at very different conclusions and have very different explanations for what happened. You may have even tried to explain your point of view to them rationally to try and convert them over to your worldview, but the other person will always seem to be able to explain what happened in the context of their own ideas or their own paradigm. Kuhn said that competing paradigms are incommensurable. That is to say, we cannot directly or objectively compare paradigms. After all, none of us have objective access to the world. Anything we see or observe must be interpreted through some lens or some paradigm. As such, Kuhn said, switching from one paradigm to another is never an entirely rational process. You can always explain the results in the context of another paradigm. Sure, some paradigms might provide simpler explanations, or some paradigms might have greater predictive power, but that doesn't necessarily make them true. No matter what you do, according to Thomas Kuhn, one of my favourite pieces of philosophy is Pascal's wager, and it goes like this. God either exists or they don't. If God exists and you choose to believe in them, then when you die, you'll probably go to heaven. If God exists and you don't believe in them, well, you're going to hell. Now, if God doesn't exist, it doesn't really matter whether you believe in them or not. So you might as well believe in God, right? Because there's only upside. Now, immediately, you might have a lot of issues with this argument. There are multiple religions to choose from. Belief doesn't work like that. There are potentially significant downsides of believing in God. But this is actually to misunderstand the context that Pascal was arguing in. Pascal wrote this argument down by saying, look, there's no way we can rationally prove God exists or not. Life is ridden with uncertainty. We're uncertain about the nature of man. We're uncertain about reason. We're uncertain about science. We're uncertain about almost everything. So in a sense, Pascal was arguing, almost everything you do is a bet. You're weighing up the possible outcomes, how likely they are, and how much you value those options. We're all gamblers in this massive casino we call life. So Pascal was saying that the rational person should try and maximize their chances of a good outcome. And the upsides of believing in God are potentially infinite. To me, this is not only really funny, but also profoundly insightful, because there really are no certainties. You could do everything right and things could not work out for you. And on the flip side, you can do everything wrong and things can work out fine. And when you see that, there can be this really rattling question of, well, why should you do good things? For some people, this bet that there's this infinite upside in the afterlife means that they'll be a good person in this one. The answer to this question that I like most came from someone who vastly predated Pascal, Marcus Aurelius. He said that you should live a good life. If there are gods and they are just, then they will not care how devout you have been, but will welcome you based on the virtues that you have lived by. If there are gods but they are unjust, then you should not want to worship them. And if there are no gods at all, well, you will be gone. But you will have lived a noble life, which will live on in the memories of your loved ones. And that's a bet that you can always win. Free will versus determinism. Are we free? Do we get to decide what the future is? My personal answer, no. Free will is a garbage, inherently nonsensical concept which we've had philosophers for the last couple hundred years desperately tried to redefine over and over and over again to try and make it somehow compatible with reality. Look, I'm not saying you don't make choices or that you don't experience being free to choose. I made the choice to make this video. I feel free, I get it. But just because something feels true doesn't mean it is. You and I make choices every day for reasons we didn't choose and we don't control. If you were free, why would you ever make the wrong decision? Your body is made of stuff. And stuff obeys deterministic causal laws, the laws of physics, which means that so do you. If you lose a particular part of your brain, you lose the functionality associated with it. If we replaced every part of your brain with someone else's, you would be someone else. Why? Because we are our brains, we are our bodies, and they're physical things. And physical things obey laws. Look, if you believe in free will, I'm ready to be convinced. Where is it hiding? Is it in the brain? Where? Where is it? But wait, I hear you cry. Quantum physics is indeterministic. It functions with probabilities, which means we're free? Firstly, depends on your interpretation of quantum physics. Many of them are deterministic. Secondly, there is speculation around whether consciousness is a quantum phenomena, but there's no hard evidence. But even if it turned out that the future is not determined because of quantum physics, and that consciousness is a quantum phenomena, that wouldn't give you free will. That would just mean that you are random, and random isn't free. If consciousness really relies on quantum randomness, that means every time you make a decision, that's like a quantum coin toss as to which way you'll go. Try flipping a coin for every decision you ever make. You won't feel free, trust me. Now why does this matter? Why does this annoy me so much? Because so much of our society and systems of living are predicated on the idea that people could have done otherwise. Big example, the justice system. Rehabilitation always takes a backseat to retribution, because the punishment of criminals is the right thing to do because they chose to do the wrong thing. Maybe they made that choice, but that was because of their brain structure, which they didn't choose, or their upbringing, which they didn't choose, or their genetics, which they didn't choose. Look, on an emotional level, I get it. I want my enemies to suffer, but rationally, I know that punishment for punishment's sake alone makes no sense whatsoever. Punishment that serves rehabilitation, or protection, or even deterrent, maybe there's an argument there. But because free will doesn't exist, moral retribution can go out the window. Another one, the economic idea that people should pull themselves up by their bootstraps and everyone's free to innovate and work harder. What if they literally don't have the ability to do that? Suddenly our economic system seems a lot crueler, doesn't it? Now, does this mean we should stop trying to make ourselves better or society better? No, these are good ideas and useful for our subjective illusions. It just means that whatever's going to happen was going to happen anyway. Look, at the end of the day, there's overwhelming evidence that the decisions you make were born by the factors of your genetics and your upbringing, neither of which you control. Even if you do believe in free will, there's like a tiny margin, like we're not free to do a lot, surely, right? So if we can agree that almost everything you do is determined, if not everything, but like whatever, then why doesn't it affect more of how we do everything? But hey, if you disagree, I can't blame you. You are always going to. Look, I know this is a personal question, but are you a philosophical zombie? What I mean by this is, do you have a subjective experience of what it's like to be you? I know you can tell the difference between hot and cold and what it's like when you're injured and all that, but what does hot feel like to you? Like, how do I know that your hot feels the same as my hot? How do I know that when you see red, you see the same color that I see red to be in? We're not just distinguishing it. What if instead of having a different experience, you don't have an experience at all? This thought experiment of philosophical zombies basically asks how we would know if anyone around us lacked something called qualia. Qualia is basically a word for subjective experience, like the inner experience or the mental state associated with being you. Now, perhaps we could imagine building a robot or an artificial intelligence so advanced that it behaved identically to a human. How would we know if it had a subjective experience, if it behaved exactly like a human? Could we ever know? But more importantly, how do you even know that anyone besides you has an experience of anything? I might just be a philosophical zombie. I speak and act like I'm conscious and I have experiences, but that just might be language and learned behavior. There might be no ghost in my machine. There might be no ghost in any machines, apart from yours. You might be utterly alone behind those eyes of yours. Or of course you could draw the complete opposite conclusion, which is that no, not only do all people have qualia, have an experience of something, but all living things do. Like a fish knows what it's like to be a fish, a grasshopper knows what it's like to be a grasshopper. Hell, even a bacterium has an experience of what it's like to be a bacterium. This problem of qualia is called the explanatory gap. It's not clear how, even if we had an objective understanding of how the neurons in your brain were all wired together or how the neurotransmitter fired, that we'd know what produced this subjective experience of you being you. Now, if you believe that consciousness arises from physical processes of some sort of strange feedback loop, then you're forced to concede that not only does every living thing have some sort of subjective experience, but many non-living things do as well. Does a computer have an experience of what it's like to be a computer? Is there a texture to the experience of running a Word or Excel program? Or perhaps you believe that this is just one of those unanswerable problems, in which case when you look into someone's eyes, you'll never really know if they're a zombie or not. What is probability? Consider these two statements. There's a 50% chance it will rain tomorrow, and there's a 50% chance this coin will land on one side rather than the other. These two statements seem similar, but if we analyze them, it looks like they're making very different claims about reality. Let's look at the coin example. What do we really mean when we say that there's a 50% chance of it landing on one side? What does that actually translate to? Intuitively, you might say that, look, if we flip the coin 10 times, half of them will be on one side and half will be on the other, or at least roughly that amount. If we flipped it 100 times, roughly 50 would be on one side, 50 would be on the other, and so on. This 50% ratio would emerge with repeated trials. But of course, that can't be the case for the weather example, because we can't repeat tomorrow. Tomorrow's only going to happen once. Let's say that it did rain. Even if we could repeat tomorrow, even if we could repeat the day, then presumably it would rain every single time. The weather's always the same on Groundhog Day. These two examples illustrate the problem of the interpretation of probability. In the weather example, we're not really talking about repeat trials. Generally, we're talking about our degree of belief, how confident we are in our predictions. This is the subjective interpretation of probability. In the coin example, perhaps something called the frequentist interpretation of probability makes more sense. In this interpretation, probabilities represent our best guess at future ratios. We're using raw empirical data to make predictions. But there are problems with both of these interpretations. In the subjective view of probability, it depends on the rationality of the agents involved. It's subjective, it's not objective, which is what we'd like. And the frequentist interpretation of probability has an issue as well. Let's unpack the definition. Probabilities are our best guess at future ratios. Well, what's our best guess? Well, it's the most likely one. Well, what's the most likely? Oh, it's the most probable. So probability is our most probable guess at future ratios. That means our definition of probability is circular, it's self-referential. And that's not great. And there are actually many other interpretations of probability. There's the classical interpretation, there's the propensity interpretation. And each of these interpretations seems to apply or be more useful in different situations. But as unlikely as it might seem, each of them have their own problems as well. So the next time that someone tells you that something is likely to happen, ask yourself, the time I turned myself into a Chinese room. Okay, so the Chinese room was a thought experiment invented by philosopher John Searle as an argument against machines actually having consciousness regardless of how intelligently they behave. And it goes like this. Suppose we lock someone who didn't speak Chinese in a hotel room. Outside the hotel room, we've got someone who does speak Chinese, who communicates with the person inside by writing the messages in Chinese and sliding them underneath the hotel room door. Now the person inside the hotel room, who doesn't speak the language, is tasked with replying to them in Chinese. Luckily for them, they've got a book in their hotel room. The book doesn't teach them Chinese. Rather, it simply states that if you receive a letter containing these symbols, these characters in this order, then reply with a letter containing these characters in this order. It doesn't detail the meaning of these characters whatsoever. It's a simple, if you get this input, then reply with this output. So, the person in the hotel room, when they receive a message, looks through the book, finds a page which matches the message that they received, and copies the reply detailed in the book, and slides it back underneath the hotel room door. When the person outside the hotel room receives the reply, it's in perfect Chinese, it makes sense given the message that they sent, so they think, oh, this person inside the room speaks the language as well. When of course the reality is that the person inside the hotel room doesn't speak the language at all, they're just executing a program. This is John Searle's argument. He basically says that no matter how convincing an AI is, even if it can pass the Turing test, which means that it can pass for a human, an AI is basically doing what this person inside the hotel room is doing, which is that it's simulating understanding. It doesn't actually understand it itself. I have a funny relationship with this thought experiment because one time I actually did this experiment myself. When I was 16, as part of my examinations that year, I had to do a spoken exam for French. Despite having been taught it for 10 years in school, all I knew was je ne sais pas, which means I don't know. So, knowing that I couldn't speak French, I found a huge list of all the possible questions or topics that they could ask me in this exam, and I wrote a 3-sentence reply for every single one of them. And for several weeks, I memorized all of them. Every morning, every night, I would recite these. Very quickly, I forgot what they meant. My plan for the exam was, I'm gonna go in, my teacher will make this series of noises, and I'll reply with this series of noises, and then I'll pass for someone who knows French. So I go into the exam, they're making some French noises that I recognize, I'm replying with my French noises, it's going great. And then there's this one question which, translated to English, meant something like, oh, which would you prioritize first, your career or your personal life? And my answer in French was meant to mean something like, oh, you know, I'd like to sort out my career first, and then I'd like to get married. But apparently what I said was, I'd like to sort out my career first, and then I'd like to marry you. Now bear in mind, I didn't understand what I was saying, so I'm just sitting there thinking I made the French sound. Whereas my teacher, who's a great guy, just sort of paused and sort of looked at me blankly like, did you mean to mean that? And when the time was up, he stopped the recorder and then said to me, well, Jack, I'm very flattered. And then he calmly explained to me what I had said and asked me why I had looked so confident saying it. So yeah, appearing to understand does not mean that you actually understand. And that was, do we live in a simulation? This idea, this hypothesis or argument has many versions, but the one I'm going to talk about today was the one put forward by Nick Bostrom back in 2003. His argument is this. He presents us with a trilemma. One of the 3 following statements is likely to be true. Number 1, all human civilizations go extinct before ever reaching a post-human civilization stage. Basically a technologically advanced stage where they can run awesome simulations. Number 2, any post-human civilization would be entirely disinterested in running evolutionary simulations of their ancestors. Or number 3, we are most likely living in a simulation. If the first two statements aren't true, namely that human civilization does reach a stage where they can run awesome simulations, and at least some fraction of that civilization is interested in running simulations, then because they'll have access to such vast amounts of computational power, the vast majority of humans that will ever exist will be simulated ones. Therefore, statistically, it's far more likely that we're simulated than we are living in base reality. I mean, think about it even today. In terms of video games, there are far more virtual characters that are rendered than there are real people. So imagine what that ratio is going to be like in the far off distant future. A lot of people really like this argument, and a lot of people don't. Some of the most common criticisms of this argument include the fact that we have no idea if simulated humans would be conscious in the same way that physical, real ones are, if we assume that we're real physical ones. Secondly, you could also possibly accuse the argument of contradicting itself. It sort of assumes that we're living in the real world, extrapolates that to argue that we're not living in the real world. If we're living in a simulation, how do we know that our simulators resemble us in any way? As we know from video games once more, simulated worlds do not need to bear any resemblance to the real one. But a lot of people really like this argument and this idea because they think it provides an elegant explanation for a lot of the weirdness in the world. Some people say that quantum weirdness might just be resource optimization in these big computers that are simulating us. It's a technique used in video games whereby the computer will only render what the player is looking at. I'm very suspicious of this type of reasoning because I think the idea of a simulation is so sort of loose and with so many unknowns that you can kind of twist the explanation into explaining away anything you like. I think it's guilty of the same problems that people have when they say that God is responsible for something. I mean, think about it. If you believe in a simulation, you believe that there's an all-powerful, all-knowing creator who literally created us in their own image. The idea sounds familiar somehow, you know, but I think one of the best ways to analyze this argument is to compare it with another argument which uses a similar style of reasoning to arrive at a vastly different conclusion. It's called the Doomsday Argument, and we'll talk about it next time. Suppose you suspected that you had a rare disease. This hypothetical disease only affects 1 in 10,000 people. You go to a doctor who gives you a test which gives the correct diagnosis 99% of the time. That is to say that if you have the disease, it will tell you correctly that you do 99 times out of 100. And if you don't have the disease, it will tell you correctly that you don't 99 times out of 100. You take the test and it comes back positive, saying that you do in fact have the disease. What is the likelihood, what is the probability that you have the disease given this information? Instinctively, you might think, well, it's obvious. I'm 99% likely to have the disease. But actually, you're less than 1% likely to. Sounds ridiculous, I know. Let me prove it to you. Suppose we took 1 million people from the population. Because this disease affects 1 in 10,000 people, 100 people will have the disease, and 999,900 people will not. And let's say we gave this test to everybody. Out of the 100 people who genuinely have the disease, 99 of them will receive a correct, positive result, saying that they do in fact have it. But because the test is only correct 99% of the time, one of these 100 people will be told incorrectly that they do not in fact have the disease. All makes sense, no surprises so far. Now let's consider the people who don't have the disease. 99% of them will be told correctly that they do not in fact have the disease, and that works out to 989,901 people. But of course, 1% of this group will receive an incorrect positive result, and that comes out to 9,999 people, which is far more than the 99 people who received a correct positive result. It's far more likely that you're in the group that was misdiagnosed. The probability that you actually have the disease is 99 divided by the sum of these two numbers, which works out to be 0.98%. Now, of course, this is a simplified example. In the real world, a doctor is going to be factoring in a lot more information to arrive at a diagnosis. Not only that, tests will often have very different false positive compared with false negative rates, meaning that it will diagnose people who don't have the disease incorrectly at a very different rate than it will diagnose people who do have the disease incorrectly. The reason why I like this example is because it's a tangible demonstration of how counterintuitive statistics is for people who haven't studied it, and how we naturally ignore information which might be really important for arriving at a logical conclusion. Yeah, so there are a bunch of questions like this asking basically whether I'd fudged the numbers by assuming that 1 million people got the test. And that's not the case. Actually, the probability doesn't change regardless of how many people take the test. So obviously we used these numbers last time. I did this because I find it personally much easier to visualize when we have a sort of tangible sample size as opposed to a much smaller one. So let me show you how the numbers don't change. Let's say we 10 times this sample size. Well, obviously we would have 1,000 people rather than 100 who would have the disease, and 9,999,000 who do not. So from there we basically got 10 times everything. We have 990 people who get a correct positive result, and 99,990 people who get an incorrect positive result, a false positive. And so the percentage chance that you actually have the disease becomes 990 divided by the sum of these two new numbers, which once again turns out to be 0.98%. So now let's shrink the sample size. Let's do this with just one person. The probability that you have the disease is 1 in 10,000, so we can divide up the possibilities like this. And as you can see, we just get a long string of decimals for each. But if we crank through the maths, once again, trust me on this, it comes out to 0.98%. Even if you're the only person who takes the test, if we know that disease affects 1 in 10,000 people, and the false positive and false negative rates are what we describe in this example, then you getting a positive test result means that you have a 0.98% chance of having the disease. Another way of thinking about it might be that without the test, you have a 1 in 10,000 chance of having the disease, and then taking the test, that increases your chances of having the disease from 1 in 10,000, which is way less than 1%, to close to 1%. So it sort of bumps you up in likelihood by taking a test. Now, how do we fix this? Well, ideally, our tests have as low a false positive rate as possible. If we imagine a scenario where our test just has a false positive rate of 0, then as you can see, the only people who get a positive test result are the people who actually have the disease. There is that one person who gets a false negative result, and that's still a problem, but this means that in this scenario, if you had a positive test result, you know you have the disease. So in the case of rare diseases, the false positive rate is kind of the thing that we want to make sure is as small as possible in order to be confident in a diagnosis following a test. The end is nigh. It's the Doomsday Argument. Suppose you were presented with 2 jars. One jar has 10 balls in it, each labelled from 1 to 10, and the other jar has 1,000,000 balls in it, each labelled from 1 to 1,000,000. You don't know which jar is which. You pick a jar at random and you take out a ball and it has the number 7 written on it. Which jar did the ball come from? Now, technically it could have come from either. Both jars have a ball with the number 7 labelled on it. Obviously, if you took out a ball with the number 11 or 100 or 999,000 printed on it, you'd know it came from the jar with 1,000,000 balls in. But because you got lucky number 7, you can't be sure. However, it's far more likely to have come from the first jar, right? If you're reaching into the first jar, there's a 1 in 10 chance of getting a 7. But if you're reaching into the second, there's a 1 in 1,000,000 chance. So it's far more likely to have come from the first. Okay, so this is all great, but what the hell does this have to do with Apocalypse? Well, we were born during this recent era, and as far as we know, right now, there are the most amount of humans that have ever existed on the planet ever. If the human race survives this decade and goes on to colonize other planets and galaxies thousands and millions of years into the future, our population today will seem vanishingly small compared to the population of the human species in the far off future. The Doomsday Argument basically says, isn't it rational to believe that you were born at a time that it's most likely for you to be born in? Because, obviously. So either we believe that we're insanely lucky, or unlucky, depending on how you look at it, to be born at a time where there are hardly any humans compared to this far off distant future, or we just think that this is expected. This is the most likely time to be born in. And if we say that, then that means that the human population has basically peaked, that that far off distant future doesn't exist, that we're in the first jar, we're lucky number 7, and the balls only go up to 10. Metaphors we live by. Argument is war. Their claims were indefensible. I attacked their weak points. Liberal/conservative gets destroyed. Compilation. Love is ironically often characterized by physics. There was electricity between us, a chemistry. I gravitated towards them. Our relationship lost its momentum, or sometimes even like a sick patient. We have a strong and healthy marriage. Our relationship is on the mend. Our relationship is on its last legs. We use metaphors as naturally as we breathe, and they're extremely useful. However, sometimes they can be misleading. For instance, have you ever needed to let off steam? Have you ever needed to vent? Interestingly, thinking of people like steam engines came about as the steam engine became more widely used. The idea of venting was a popular metaphor used by Freud. However, research has actually shown that by venting, like beating your pillow or screaming, actually tends to make us more aggressive, not less. It legitimizes our feelings of anger or anguish, rather than relieving them. What are some modern day metaphors we use? My social battery is dead. I just need to disconnect, recharge. That's not how I process things. This is me 2.0. These metaphors might be useful, might be true in a certain context, but they may not be entirely true. It may not be that you need to disconnect completely, but just spend time with someone else. Maybe you don't need a software update. Maybe you just need a break. Maybe your social battery isn't dead, you just have crappy friends. So the next time you use or hear a metaphor, just think to yourself, is that true in all aspects? Or is this potentially a thinking trap? Or dead end? Or mistake? What is Stoicism? Stoicism was a school of Hellenistic philosophy that was founded by a guy called Zeno of Citium. What this school was just a bunch of philosophers coming together talking about what philosophy was meant to be about, which is how to live a good life. How should we navigate this crazy world we live in? These ideas basically developed after the work of Plato, Aristotle, and Socrates, and there were lots of other competing Hellenistic schools as well. You had the Epicureans and the Skeptics all around the same area, and they would get in these debates about the nature of reality and how to live in it. Stoicism was developed by many individuals. Perhaps 3 of the most notable were Epictetus, Seneca, and Marcus Aurelius. Marcus Aurelius was the literal emperor of Rome. Seneca was the statesman, and Epictetus was a slave. These 3 men, whose lives couldn't have been more different in the societies in which they lived, arrived at the same fundamental conclusions about how to live. They said that the vast majority of things are outside of our control. You can't affect how people think about you, you can't change the circumstances in which you were born in, you can't affect what fate has planned for you. You can only control your thoughts, your attitude, your actions. If anything upsets you or causes you anxiety or fear, it's because of your judgment on that thing. You control your mind, so you should take control of it, and only value that which you can control. The Stoics assert that living a good life is not necessarily about accruing riches or even being happy. It's about being virtuous. That virtue is enough. The 4 cardinal virtues of Stoicism are wisdom, justice, prudence, and courage. This philosophy, this idea of focusing and shrinking down to your inner citadel, that which you can control, your inner mind, your inner thoughts, is very well stress tested throughout history. Many people who wouldn't be identified as Stoic come to the same fundamental claims about reality, and the ideas in Stoicism are extremely similar to those used in cognitive behavioral therapy, a therapy used for people with anxiety to live better lives. One of the best books on Stoicism, in my opinion, is A Little Happier by Derren Brown. There's a longer version of this book, but this book is barely 100 pages. Anyone could read it in a couple of hours, so I would highly recommend you check that out. There is no scientific method. That was the position argued by Paul Feyerabend. Any law and order style attempts to boil science down to a certain set of methods will only inhibit its progress. The only principle that doesn't inhibit progress is that anything goes. Feyerabend was an outspoken epistemological anarchist, once referred to as the worst enemy of science. He wasn't anti-science, he was a trained physicist and strongly believed in its power. What he didn't like was science as this one big monolithic structure, science as a dogma. Instead, he liked to view the sciences as very different disciplines, all interested in generating knowledge, but using different methods and different approaches. But you can see why he earned his reputation, because he said things like, neither science nor rationality are universal methods of excellence. They are particular traditions, unaware of their historical grounding. He said that science is neither a single tradition nor the best tradition there is. He argued against the idea that science was free of biases or values, saying that if you look at history, science has been greatly informed and directed by our culture and our heritage. And he said we have an obligation to recognize this and think about science a little bit more carefully. Otherwise, we're going to hold back progress. Arguing for the principle of anything goes, something that's going to advance our scientific knowledge or thinking, is outside the current realm of scientific thinking right now. It has to come from somewhere. Oftentimes in the history of science, new revolutionary ideas don't just agree with current data and make more predictions, but actively disagree with the current data. He uses examples from Copernicus and Galileo, whereby people had to disregard their intuitions around how motion worked. One of the early challenges against the idea that the Earth rotated and the sun didn't revolve around it was that you could take a ball and drop it from a really high place and it would land directly underneath, rather than what you might expect if the Earth is rotating underneath it, it would sort of fall far away. Why that doesn't happen makes sense to us now with our understanding of momentum and inertia, but they didn't have those ideas back then. It was counter to observation and intuition. I think he makes some really important points, and many philosophers agree that there is no single scientific method. In chemistry, you can test a reaction again and again as many times as you want, as long as you have the materials. But with astronomy, you can't exactly ask a supernova to explode one more time. Whether total anarchy really is the answer remains to be seen, but you can understand why he was a controversial figure. As you might expect, not many scientists were a fan of the idea that solipsism, the belief that you are the only thing that's real. Like many philosophies, solipsism comes in many different forms. The common understanding of a solipsist is someone who believes that only their internal experience is guaranteed to be real, with all other external phenomena, such as their friends and family, animals, the world around them, the entire universe, isn't guaranteed to exist. It might all be an illusion, a dream, in their mind. So in a way, this sounds like a really hardcore philosophical version of narcissism, right? The world doesn't revolve around you. No. You are actually the entire world. There is actually a syndrome associated with it called solipsistic syndrome. This is where someone feels that reality isn't really external to their mind. That line gets a bit blurred. But putting the syndrome to one side, the philosophical viewpoint is actually really worth considering, even though convincing someone else to become a solipsist basically means convincing them that you don't exist, or that they don't exist. There are two kinds worth considering: epistemological and methodological. Epistemological solipsism is kind of the hardcore kind, where they say, look, we can't really be sure that anything outside of our internal experience is really real. For all you know, you could be a brain in a vat, you could be plugged into something like the Matrix, there could be some deity manipulating your experiences. It doesn't mean it's not real. Our brains could actually be in our skulls and this could all be physical reality. It just means we can never really know. Methodological solipsism is a bit more optimistic. It says, yes, our direct connection with reality is our immediate experience, but that should be a starting point upon which we build all of our knowledge and understanding about the world. It shouldn't just stop there. And I think this is actually something really worth thinking about, because the idea that you're the only thing that's real and that all of this is happening within your mind is logically consistent. I can't give you any evidence to prove that's not the case, but there are infinitely many logically consistent theories out there, and the way to dismiss or move past the idea that this is all a dream is to hold it up to argument and scrutiny. Things like Occam's razor, like, yes, it could be the case that we're all brains and vats, but if you believe that, you kind of do believe in a real world, just with lots of extra stuff added onto it. Like, why would your brain be in a vat? You need to explain all this other stuff. We all live our lives like this reality is real, so let's go with that as our best explanation until evidence suggests that we should be skeptical once more. The problem with Stoicism. There are actually quite a few, but one of the key ones for me is this. Stoicism asserts that the only things you can control are those in your internal world. That is your thoughts, your actions, your attitude, and so on. The problem is that while this is a very empowering thought, perhaps even a useful one, it's not true, or at least it's not always true. For instance, we all know that when we're drunk, we're kind of in a sense poisoned, right? We can't just think ourselves sober. In that state, we're not in full control of our actions or our thoughts. That's why people drink. But alcohol isn't the only reason why that can occur. Depression, addiction, sleep deprivation. These are all states which have a neurochemical basis. They're all physical states of your brain. And to say that someone's always in control of their thoughts, I think is misleading, because it implies that someone can think themselves happier or think themselves out of addiction. And that doesn't seem to be the case. I sometimes think about the story of Odysseus and the Siren Song. During the adventures of Odysseus, there was a part whereby him and his crew had to row past the Sirens, who sang a song which would drive men to madness and insanity. What Odysseus did in preparation for this was to pour wax in all of his sailors' ears to sort of deafen them. But he didn't pour wax in his own ears. Instead, he had his sailors tie him to a mast and ordered them to fight him if he broke free of his constraints. So with all this preparation, when the sailors were going past the Sirens did indeed sing. The sailors with wax in their ears didn't hear anything. But Odysseus was driven to madness. He was thrashing against his constraints, trying to break free. Even though logically he knew that if he actually succumbed to those calls, he would end up dying, he wasn't able to resist. And because he knew that, him and his crew were able to survive at least that part of the journey. The story would have been very different if Odysseus had gone, I'm a Stoic. I'm in control of my thoughts and actions. At first it can seem like a very scary idea to admit that you're not fully in control of your thoughts and actions at all times. But I think if you accept this, it's actually a very liberating thing, because it allows you to be more intelligent and to prepare for situations which you won't be able to resist the temptation of. In the 12-step program, one of the earliest steps is to accept that you don't have control over your addiction, which is completely antithetical to the Stoic idea of always being in control of yourself. At the end of the day, I think there's wisdom in both these approaches. Yes, we should strive to be in control of ourselves at all time, but few of us live up to that ideal, so perhaps the best way for us to live is to strive for self-control, while also accepting that sometimes we might need to tie ourselves to a mast, and true freedom comes from knowing, accepting, and acting upon that fact. The story of the invisible college which shaped modern science. So this society existed over 350 years ago, and started out as 12 rather unlikely individuals who banded together with a common goal: to discover knowledge about the world through experiment and evidence. They included a mathematician, a natural philosopher, an astronomer, but also a merchant, an inventor, and a royalist exile. So their first official meeting was on November 28, 1660, but we know that they'd been meeting for around 15 years prior because we have letters from the various members where they write to each other referring to our invisible college. Their motto was nullius in verba, which translates to take nobody's word for it. You've got to understand that back in 1660, a scientist wasn't a thing. That concept didn't exist. That word wouldn't even be invented until 1834. Academia existed, yes, there were universities, but most of study and most of knowledge was acquired through studying old and ancient texts, or through divine revelation justified by authority. Galileo's run-in with the church had happened around 30 years prior, whereby the church accused him of heresy for suggesting that the earth rotated around the sun rather than the other way round. So their motto of take nobody's word for it was really take nobody's word for it unless they can provide evidence. We're done with just trusting authority, we need experiment, which at the time was a radical idea. So, soon after their first official meeting, they ended up recruiting a lot more members in the coming years, and they became quite well known. And what ended up happening was that the king at the time, King Charles II, gave them royal approval, and they became known as the Royal Society. So suddenly there was a social credibility to this group of people, and besides putting an emphasis back on experiment, the Royal Society did something else crucial for science. In 1665, they started publishing their findings. They called it Philosophical Transactions, and this was kind of like an early form of what would become a modern scientific journal. The first volume had an article on how to improve optic glasses, a spot on Jupiter's belt, and an account of a very odd, monstrous calf. Science has got to start somewhere. And soon afterwards, they wouldn't just publish the experimental results, but also record the witnesses of those experiments. They would get people in to watch what was happening. So when they published what happened, there was testimony. Not only do we have evidence now, but we also have trust. And those are foundational ingredients to learning from each other, which is crucial to modern science today. And that was, does it matter whether we have free will? This is a surprisingly thorny question to answer, mainly because there are many different ways in which you can define free will, and many different contexts it can apply to. Whether that's legal judgments, ethical judgments, not the same thing, or just how you go about understanding your conscious experience of a living person in the world. You can define free will in a way that's compatible with the idea that the future is deterministic. However, I feel like the more intuitive and more useful definition of free will is the idea that the future is yet unwritten, and that someone is free if they get to make choices which decide their fate, rather than having their fate decided for them in advance. That feels like an actually free will to me. And cards on the table, I don't think that exists. I think the future is determined. I think whatever choices we make, we were always going to make. And that's not to say that I don't think people can change, or that people's lives can go in a different direction. All it's to say is that they were always going to change, or their lives were always going to go in a different direction. And if you don't believe in that kind of free will, then the answer to the question of, well, does it matter, is a sort of yes and no. Yes, it absolutely matters that I don't have free will, That's not ideal. And no, it doesn't matter, because there's nothing I can do about it. But whether you share my disbelief in this kind of free will or not, there's a certain sense in which I think it doesn't matter at all, and that is how you live your life. Despite the fact that I don't believe in this kind of free will, I still have to bear two things in mind. One, I still psychologically, subjectively feel like I need to make choices. That hasn't gone away. And two, I may be wrong. And I feel like the most logical thing to do, given that, when it comes to your own decisions, is to actually live as though you do have free will. Because suppose I'm wrong and free will does actually exist. If I freely choose to live my life as though I don't have any agency, that is a huge waste. That is a waste of this amazing superpower that is free will that I have. Whereas if I choose to live as though I'm free, and I am actually free, then I'm taking advantage of this amazing thing. But if this free will doesn't exist, then whatever I do, I was always going to do. So by living as though you do have free will, by leaning into that subjective experience, when it comes to decisions, only has an upside. Now this absolutely changes when it comes to ethical and legal judgments. If people aren't truly free, then it becomes very difficult to hold them morally accountable for whatever actions they choose, because they weren't really free to choose otherwise. Is philosophy dead? I assume you're referring to Stephen Hawking, who famously declared, "Philosophy is dead," and went on to say that scientists have become the bearers of the torch of discovery in our quest for knowledge. So his point is correct, but his conclusion is wrong. On the one hand, undoubtedly, yes, science today produces more knowledge than philosophy does, and arguably it's become much better suited to answer age-old philosophical questions like, where did we come from? Why are we here? And even fields like neuroscience or psychology are beginning to have insights on seemingly fundamental questions like, what makes for a good life? But to my mind, to say that philosophy is dead because it doesn't produce as much knowledge as science does is to fundamentally misunderstand what philosophy is about. I was once told that philosophy is the only degree in which, if you did it right, you graduate knowing less than when you started. This is because the value of philosophy comes not from providing answers, but from asking questions. It doesn't create knowledge so much as it reveals where it's lacking. It undermines what we consider to be obvious. It creates space. It tests our foundations such that we can build them back better. In my mind, science is the other side of that coin, the coin of truth. It does the answering. It fills the space, which is why I studied both. The word philosophy comes from the Greek philosophia, which literally translates to love of wisdom. That's not love of knowledge, that's love of wisdom. And much of wisdom is in identifying and recognizing your own ignorance such that you can address it. Would modern philosophy be improved if more philosophers understood science? Absolutely yes. But then, so would politics, so would society at large. Many things would be improved. But the reverse is also true. Science would be improved if more scientists understood philosophy. If anything, I think philosophy is more alive and more needed than ever. We're confronted with philosophical questions daily, whether it's the political philosophy question of security versus liberty in a time of disease, or new ethical dilemmas from new technologies, and even sci-fi questions around consciousness and robots are on the near horizon. As we develop more and more advanced AI, we're going to have to ask, does it have consciousness? And if so, does it deserve human rights? But now that you mention it, what do we mean by dead? Well, in order to answer that, we're going to need a beginner's guide to Western philosophy. I feel like philosophy can seem like this really abstract, amorphous subject that can be quite unapproachable and hard to get a handle on. So what I'm going to do in this video is try and lay it all out. Philosophy today is generally divided up into several different fundamental branches, though naturally philosophers will quibble about how many different branches there actually are. Some will say 4, some will say 6, but to my mind, there are actually 10 usefully distinguished different branches of philosophy, and we're going to go through them now. To begin with, we have aesthetics and ethics, although sometimes these are clumped together under one label called axiology, the philosophy of value. The reason why I don't like this label is that no one's heard of it, and labels are meant to be useful. So, aesthetics is the philosophy of beauty and art. It asks questions like, what is beauty? Why do we find certain things beautiful and not others? And what makes for good art? What even is art in the first place? Then we've got ethics, which hopefully shouldn't be too new to you. This is about moral judgments, good and evil, right and wrong, and what makes for a good life. Next up, we've got epistemology, which is the study of knowledge. This asks questions like, what is knowledge? And how is that different from belief and truth? Are there any rational beliefs? What is truth? Next up, we've got metaphysics, and this is the study of fundamental entities. Things like identity, change, causality, space, time. It is easily the most memeable branch of philosophy because you ask questions like, what is this? Why does it have those properties? What does it mean to be one thing and not another thing? Next up, we've got logic, which is sort of hard to define. It deals with formal, rational argument. Within this category, we've got mathematical logic, which closely leads into the entire field of mathematics. So those first 5 are kind of the fundamentals, and these next 5 5 are kind of mixtures of those. So then we have philosophy of mind, which asks questions like, what is consciousness? Could a robot be conscious? The mind-body problem. How does consciousness arise from physical matter? Does it? Then we've got the philosophy of religion, which, as you'd expect, studies the philosophical claims and arguments in the various different religions around the world and throughout history. In this, you'd have everything from arguments around the existence of God, the problem of evil, to even looking at Buddhist and Hindu doctrines. And we've got philosophy of science. This is the good stuff. This asks questions like, what is science? What is the scientific method? Is there a scientific method? Can science be improved? What separates scientific knowledge from other kinds of knowledge? Then we've got political philosophy, which considers questions around liberty, law, justice, rights, property, what should the relationship between state and citizen be, and so on. And the last branch, and probably the most controversial one I put in here, is existential philosophy, asking questions around the meaning of life or absence thereof. If there is no meaning to life, why should we go on living at all? Why bother? Why are we here? That sort of thing. Now there's overlap between all of these, and within all of these branches there are sub-branches, anything from the philosophy of film to the philosophy of time. Philosophy can get as niche as you like. So if any of these have piqued your interest, please check them out. I've left a link via my profile to a bunch of different philosophical resources. What I'd also recommend is to actually chat about some of these questions and ideas with people close to you. Everyone's a philosopher. Everyone has thought about at least some of the questions that I mentioned in this video. To unlock them, sometimes all you need to do is to ask the right question.
The philosophy of Ferris Bueller's Day Off.
Life moves pretty fast. You don't stop and look around once in a while, you could miss it.
Ferris Bueller embodies the idea of carpe diem, seize the day, take back your life. What's unusual in this movie is that, as a main character, Ferris and his philosophy don't actually change throughout the film. He has no character arc. Instead, the secret main character of this film is Ferris's best friend, Cameron. Cameron represents the opposite viewpoint. He's afraid to seize anything. He is a stressed out, anxious, depressed, pessimistic, slightly nihilistic, unloved person. Cameron is me, and Cameron is you.
God damn it!
And Ferris has a simple solution: to push back and laugh. Sometimes to defeat fear, you've got to break the rules. You've got to subvert authority and get away with it, just so that you know you can. On their day off, they're chased relentlessly, but Ferris just laughs about it. And he can do this because he thinks,
Isms, in my opinion, are not good. A person should not believe in an ism. He should believe in himself.
and the way you get to that point is by daring to. What I also love about this film is how universally loved Ferris is. With the exception of a few characters, everyone adores Ferris, and we hear that he's helped out other people before. Ferris doesn't just seize the day for himself, he helps others do the same. Courage and joy are fires that spread. The film doesn't shy away from the fact that the next day, all three of them will be back in school, or that Ferris's carpe diem outlook needs to be tempered with a practical consideration for the future. Obviously, life needs a balance between the two, and this is a one-off. But sometimes you've got to do the irresponsible thing, such that you can happily do the responsible thing. Our world is skewed to the side of Cameron, of doom and gloom and fear. And don't get me wrong, there's plenty of good reasons for that. But the thing is, life is happening right now, all around us, in all its tragedy and glory. And we can only live today. And that is...
This photo made Einstein famous. Einstein had this radical theory that gravity is nothing more than the byproduct of the curvature of space and time.
Evan's video on this is great, you should absolutely check it out. The thing is, the story behind this photograph is actually a lot dodgier than many realize, and it actually shows how science can be deeply irrational. So to recap, it's 1919. In order to test Einstein's theory, Frank Dyson and Arthur Eddington devised this experiment whereby they're going to make two expeditions, one to West Africa and one to Brazil, in order to photograph an eclipse to see how much light is deflected by gravity due to the sun. Because the moon obviously shields the sun during an eclipse, you can photograph the stars as they're sitting behind the sun, and you can compare those photos with ones taken of those same stars at night. If Einstein's theory was correct, they expected that the stars would appear slightly out of place on the eclipse photos because their light was bent due to gravity. But here's the thing, this is also predicted by Newton's theory. You see, the idea of light being bent by gravity wasn't a novel one. It's just that in Newton's theory, light is bent by about half as much when compared with Einstein's theory. Remember this is important. So these expeditions go ahead, Eddington comes back, and he publishes his results in a paper called A Determination of the Deflection of Light by the Sun's Gravitational Field from Observations Made at the Total Eclipse of May 29, 1919. Anyway, right at the start of the paper, three possibilities are set out. Number 1, light isn't deflected, which would be the most unexpected result. Number 2, light is deflected by the amount Newton predicts, by 0.87 degrees outwards. Or number 3, light is deflected by the amount Einstein predicts, 1.75 degrees outwards, so roughly twice as much. So what did you find? Well, one set of results shows
0.86 degrees, which is almost exactly what Newton predicted with 0.87. Wait, what? Not all data agreed with Einstein's theory. There were 3 datasets. 2 photos from West Africa, which supported an Einstein level of deflection, and 2 sets of photos from Brazil, using 2 different telescopes. He had 7 photographs using a 4-inch telescope, which supported an Einstein level of deflection, but he had 18 photographs using an astrographic telescope, which supported a Newtonian level of deflection. There were more photos which supported Newton, but he outright dismissed the Newtonian ones. He cited systematic error due to heat and the fact that they were blurrier, which they were. But much of the same errors he cites would have applied to the other telescopes as well. Eddington really wanted Einstein's theory to be true. He loved the beauty of it. He wanted to support German science, as at the time Britons were calling for a post-war boycott of it. And he wanted a big discovery. He had influence and high connections, and so less influential, more dubious voices were pushed out of the story. He had dodgy data, but he won through authority. It wasn't until the late 1960s that it was definitively shown that the amount of deflection was the full value predicted by general relativity, rather than that of Newton. That was over 40 years later. We like to think of science as this purely rational, objective enterprise. We tell stories supporting that image, but in reality it's anything but that. It's full of irrationality, bias, cultural and even sometimes political influences. The most amazing thing to me about science is that it progresses despite this, or even more controversially, maybe even because of it.
What is Occam's razor? This idea is a problem-solving rule of thumb which is attributed to the English friar William of Occam, who lived in the 13th and 14th centuries. Occam's razor is the following: entities should not be multiplied beyond necessity. Often people will subtly misinterpret this by thinking that Occam's razor is the same as saying, just keep things simple, or that the simplest explanation is the best one, or most likely to be true. It's not that simple explanations are better, it's that your explanation shouldn't be any more complicated than it absolutely needs to be. You shouldn't multiply your entities beyond necessity. You shouldn't include any unnecessary fluff. Your explanation may turn out to be really complicated, not at all simple, and that's fine. All Occam's razor is telling you is make sure that all the parts of your explanation are absolutely needed. Now, as I said, this is a rule of thumb, not an absolute rule of truth. There are many cases where it can be wildly misleading. Suppose, for example, you're a doctor and you're seeing a patient who presents 10 very specific symptoms. Now, you know that there is a single disease which causes all 10 of those symptoms. So, by not multiplying entities beyond necessity, this can be explained with one diagnosis of one disease. You diagnose them with that disease. But of course, it's entirely possible for the patient to have 2 or 3 or even more diseases which cumulatively add up to this list of 10 symptoms. The simplest explanation isn't always the one that's correct. The reason why scientists like Occam's razor is simply for pragmatic reasons. It's way easier to test an explanation which has 1 or 2 components compared with one which has dozens. And you can even make a mathematical argument to say that a simple theory is less likely to be inaccurate, because the more complicated the theory is, the more assumptions there are, the more room for error there is. And even if we return to the wildly oversimplified doctor scenario, without any further information, we would understand why the doctor would, at least at first, test for that one disease which causes all 10 symptoms before delving into the multitude of combinations of diseases which could cause the same list of symptoms. At the end of the day, Occam's razor is a useful tool, not a law of nature. Here's an uncomfortable idea. No scientific theory on its own is capable of making experimental predictions. This idea is called the Duhem-Quine Thesis, and it's part of what makes science so tricky. When you're using a theory, in order to actually produce an experimental prediction, you need a bunch of other assumptions, also known as auxiliary hypotheses, in order to make the theory work, or even just vaguely tenable at all. We take so many of these for granted. Take for instance the idea that the Earth orbits the Sun and the Earth orbits on an axis. One of the early challenges against this idea was the fact that when you jump off the ground, the Earth doesn't spin underneath you, or when you drop something, it drops in a straight line. Now, of course, today we understand why those things occur, despite the fact that the Earth does spin, because we have a modern understanding of mechanics, inertia, frames of reference. But until you have that understanding, the idea that the Earth spins, or indeed rotates around something extremely quickly and we don't feel it, is a really counterintuitive idea, or indeed one that's hard to take seriously at all. Let's take another example. Suppose you have a theory which you're using to predict how much the temperature of your drink will increase when you microwave it for 1 minute. The theory is just a very simple equation. All it says is that given a certain amount of energy, the temperature of the liquid will increase by a certain amount in a certain ratio. So you do this experiment. You record the temperature of your drink beforehand, you put it in the microwave, you set it on a certain energy setting, you set the timer for 1 minute, you take it out afterwards, and you record the temperature of the liquid afterwards. Job done. In order to test your prediction properly, you need to assume that the equipment you have works the way you think it does, that the timer accurately goes for 1 minute, that the microwave has an accurate energy rating, that the energy that the microwave produces all gets transferred to the liquid and not to the mug or elsewhere in the microwave. You need to assume that your thermometer measures temperature accurately, which requires a whole other list of assumptions around how temperature conducts and the tech in the thermometer itself. If your drink isn't as hot as your theory predicted it to be, it could be that the theory is wrong, or any one of those underlying assumptions is incorrect somewhere. This is why it's impossible to test a scientific theory in isolation. You're always using supporting assumptions. For an experiment to truly be trustworthy, you want to be as rock solid as you can be on every assumption that's supporting the prediction that you're trying to test. The Duhem-Quine Thesis makes experimental science incredibly difficult, and often great historical experimenters get less credit than their theoretical counterparts. Are you a Boltzmann brain? This is a physics thought experiment named after Ludwig Boltzmann. It argues that if we take the laws of thermodynamics seriously, it's far more likely that you are just a lone brain that spontaneously and briefly formed in the vacuum of space that thinks all of this is real, than it is that all of this is actually real. The argument goes like this. Over time, all systems will approach a state called thermodynamic equilibrium. This is when there's no net flow of energy or matter. This is also generally the state of maximum entropy or maximum disorder. A simple example of this might be milk mixing in coffee or ice melting in water. Now crucially, thermodynamic equilibrium implies no net flow of energy or matter on a sort of more macroscopic scale. But even at equilibrium, the actual molecules themselves, say in a glass of water, are teeming with activity. They're bouncing around chaotically, and not all of them have the same energy. Some will have more energy than others, and that will be changing all the time. And this means that given enough time, there's a chance for a large enough fluctuation to occur that throws the glass, or any system, out of thermodynamic equilibrium, a fluctuation that would decrease the entropy. How could this actually happen? Well, the molecules might collide in such a way that the higher energy molecules accumulate on one side of the glass and the lower energy molecules accumulate on the other, so one side will become warmer than the other. This is all completely allowed by the laws of physics. It's just really unlikely to happen over a short time span. But if enough time passes, then this becomes extremely likely, if not entirely guaranteed, to happen. So here's the thing. Much like ice and water, the entire universe will eventually reach a state of thermal equilibrium, of maximum entropy. And it will stay there pretty much entirely unchanged for what might turn out to be an eternity. So, theoretically, given an extremely long length of time, enough atoms could collide in such a way to spontaneously form a human brain, one which has memories and thinks it's watching a TikTok video. Now obviously this brain in a vacuum would just immediately deteriorate and die. And you might be thinking, well, I've been watching this for a little while now, that means I'm not a Boltzmann brain. But bear in mind that this spontaneous brain could be formed with any false memories. So while you think you are remembering not deteriorating, that itself might be an illusion. Now, there's lots written about this thought experiment, and there are many different versions of it, but many come to the conclusion that if the universe exists for a long enough period of time, most of the brains that will ever exist, even if our ones are real, will be Boltzmann brains. So chances are, you are one. Thank you so much for agreeing to this interview. I'm sorry we're running late again. These things happen. Doesn't bother me. Amazing. So Stoicism is all about living a good life, right? Yeah, so it's an ancient school of philosophy made up of many different thinkers, each with their own emphasis and nuance, and there's a lot Stoicism talks about. But perhaps its central message is that a good life is a virtuous one, living in accordance with nature, and crucially, one which focuses only on that which you can control. So what can you control? Very little. Marcus Aurelius said, you have power over your mind, not outside events. So besides your thoughts, your decisions, your actions, that sort of thing, that's kind of it. I can't control how you or others think about me, I can't control the weather, but what I can do is when something happens, I can control how I react to that. There's a space between input and response. Well, that all sounds like nonsense. Excuse me? Well, it seems to me that I can control those things. For example, what other people think of me. If I go up to someone randomly on the street and punch them, I guarantee it, they won't like me. And alternatively, if I just give them a bunch of money randomly, they'll probably feel quite positively towards me. And we are also controlling the weather with climate change, so you're wrong. I won't deny that our actions can influence external events, but Stoicism reminds us that you can't guarantee that they do. Surely you'd agree that you can't totally control what others think about you. But see, I can throw that criticism right back at Stoicism. For instance, can you ever really totally control your thoughts? If I say pink elephant, I'm sure you probably thought of one. And if I say pink elephant again, oh, there it is again. Stoicism seems too black and white to me. Life is a lot more nuanced than that. So I think maybe you've misunderstood the point of Stoicism. Perhaps we can say there are two kinds of philosophy, right? Very broadly, some are about how the world is, and others are about how we ought to live in it. and Stoicism generally focuses on the latter. Okay, but surely knowing how the world works should inform how you live in it. Okay, so consider this. Why is a map useful? It shows you where the roads are. It's because it simplifies things. It actively leaves out information. It highlights and clearly separates roads and not roads. We flatten all the unique pieces of grass in a field into a green-coloured square. Now obviously, reality is complex and there are grey areas, but working from a map as a standard is extremely useful and easier to use than, say, a satellite image. Okay, I'll agree to that. So Stoicism gives us that map. The roads are my thoughts and actions, and I'm sure you would agree that these are a lot easier to control, or indeed influence, than, say, the weather. Right, but I'm still confused, because on the one hand, a lot of Stoics talk about fate, and on the other hand, they talk about making free choices, which seem contradictory. Generally, the Stoics were fatalistic, and literally believed in the fates, as in the three fates, the gods. Epictetus essentially thought we were actors in a play written by the fates. Marcus Aurelius did say, "Whatever happens to you has been waiting to happen since the beginning of time." But again, how we respond is up to us. But how we choose to act and respond will surely be shaped by what's already happened to us, and we're gonna need a part 2. You know what? I'm not sure Stoicism makes any sense. Look, Stoicism basically says, focus on the things you can control, and if it's not in your control, then let it go. Keep things in perspective, and be a good person. That's all fine and good advice, but it's about how you get there. So you believe in fate, and that things are predetermined, right? Well, actually, the Stoics go even further, don't they? You believe in amor fati, loving your fate, embracing and accepting reality as it is. Well, denying reality doesn't seem like a good idea. And along with this, you say that you have no power over outside events, only those in your internal world. No guaranteed influence over outside events, yeah. And yet, you actively try to affect the external world, which according to you is already determined. Ah, okay, I see what you're getting at. So on the one hand, we act as though our actions matter in some way because we strive to live with virtue and all that good stuff, but at the same time, fate is fate. We believe we can't really change the cards we're dealt, and we have to accept the hand we're dealt anyway, so why do we bother, right? Exactly. How do you believe in fate without being fatalistic? Surely there's a paradox here. I think arguably there is. On some level, we certainly do behave as though the future is unwritten, and we act as though to try to affect our environment, but emotionally, we practice accepting what life throws our way, and rationally, we will choose to think that it was always fated to happen the way it does. Well, if that's true, then is Stoicism not really a philosophy? It feels more like the art of rationalizing away pain however you can. That's a cynical way of looking at it. In my view, Stoicism boldly attempts to weave together 3 threads: objective truth about the world, subjective truth about the human experience, and a sense of purpose. And it does this so well that we don't notice when it jumps between those 3 threads. It's seamless. Do you ever wonder whether Stoicism's more suited to being a philosophy of hardship, as opposed to a whole life philosophy? Because the Stoics don't exactly seem to have that much fun. So I think it's certainly in many ways a defensive philosophy of life. Most Stoic insights have come from hardship and not joy. But I think there is a deep joy to be found in looking at the darker sides of life. I mean, that's the whole point of memento mori, remembering that we're all going to die. And that makes each day that much more precious. It reminds me to hug people just that little bit tighter. It's still so strange to me that even Marcus Aurelius, the literal emperor of Rome, said that he had no power over outside events and that everything was fated. I mean, he was the most powerful man in the world. Of course he had power over outside events. You know, during his life, he had 14 children, but only 5 of them survived to adulthood and outlived him. Most powerful man in the world. I didn't know that. Everyone's life is going to be met with tragedy. Emperor or not, fate doesn't care. So we do our best. We play our part. We might even fight fate. But when it comes to pass, we have to make the best of it. Somehow. What other choice do we have? Thank you so much for joining us today. I'm sorry we're running a bit late. It's cool. It doesn't matter. Great. So my first question was going to be... Because nothing matters. I see. So you would describe yourself as a typical nihilist? Well, technically, I'm an existential nihilist. What does that mean? I don't believe that life, the universe, anything really, has any intrinsic value or meaning. So you think there's no such thing as good or bad? Well, no objective good or bad, no. I think it's all just part of a shared delusion that anything matters at all. Objectively speaking, we're all just a bunch of space monkeys clinging to a dimly lit rock, hurtling through the void of space, and eventually we'll all die, and there will be no point to it all. That sounds pretty heavy. Yeah, it is. Well, surely you don't believe that nothing matters at all. I mean, why did you bother coming here today? If you didn't believe that anything mattered, why would you do anything? Well, it's not like I deny the existence of pain or pleasure or basic things that can motivate a person. I'm subject to those. It's just I don't think there's any grand reason behind it all. I came here today because it was something to do and better than what I had initially planned. Which was hanging out with other nihilists. Fair. So what's it like being a nihilist? It's kind of like you're at a Christmas party and everyone's singing the songs, everyone's all dressed up, getting festive, but you can't get past the fact that you know Santa isn't real and that this is all just made up, and that just ruins it somehow. And then for a few moments you'll forget and you'll find yourself singing along and it's great, but then you'll remember and suddenly you just can't hear the music anymore. So I get what you're saying, but this is the bit I don't understand, right? So I'm not a Christian, I don't believe in Santa, but I love Christmas. And I imagine that's true for a lot of people. Yes, it's absurd, yes, it's arbitrary, but it's also a lot of fun. What are your thoughts on optimistic nihilism? Like, have you tried creating your own meaning? No offense, but I really hate that suggestion. What, like my entire existence is just one big creative writing assignment? I'm just meant to invent my own myth of a fat man flying through the sky and throw my own party around it, deluding everyone else? That doesn't sound like a solution to me. Well, unfortunately, maybe that's the choice we're all presented with. Look, I'm not denying that it's cold and dark and hostile out, but either you go to someone else's party, you host your own, or you just end up at home alone in the dark. If anything, the fact that it is dark and cold outside means that any party you go to will feel that much warmer and cozier. Like, to my mind, the time is going to pass anyway. I might as well spend it singing Christmas carols with friends, however pointless that may be. So I actually think that nihilism doesn't make any sense at all. That if you actually think about it, the idea that life, the universe, and everything is all meaningless, that in itself is a meaningless idea. I don't understand. Well, nihilism sounds like it's making a claim about reality, right? That there is a lack of meaning in it. But what would meaning look like if it did exist? Obviously, some people believe in a divine being or God, which obviously you don't believe in. No, and I'm not about to. I'm not asking you to, don't worry. It's just that you say that there is an absence of meaning in the universe. So I'm asking, what would a presence of meaning look like? How would you know if it did exist? I guess there would be evidence. But what kind of evidence? Give me specifics. What evidence could I possibly provide to either prove or disprove the existence of a great meaning in the universe? Like, give me some goalposts here. You don't trust divine revelation or scripture, and frankly, neither do I, and surely you wouldn't trust personal conviction or some fleeting feeling. So what would it be? Well, in all of our scientific exploration of the universe, no meaning has popped up. Like, there's nothing there. No, okay, so you use the idea that science hasn't found any meaning as though it was some grand discovery. Like, oh no, we looked everywhere for meaning and we couldn't find any. But this isn't a conclusion of science, it's baked into the assumptions of how we do science. Science inherently separates what is from what ought to be. And that's really useful, don't get me wrong, in the same way that a box is useful because it holds empty space. But that doesn't mean we should live life that way. And hell, even if science could detect meaning, which it can't, absence of evidence is not the same as evidence of absence, so your argument would still be wrong. Okay, I accept there's no scientific test for meaning, but given science works so well, better than anything we've come up with before, and it describes a meaningless universe, why wouldn't I trust it? Ah, you're so close. Science doesn't say there is no meaning. Science doesn't have a word for meaning. So in a scientific context, that question is meaningless. And there is no good answer to a meaningless question. It's an incompatible idea with the worldview you have, so of course you think life is meaningless. In your eyes, it's impossible. It's like you're watching a black and white movie and you're complaining that there's no color. And even if some divine being from above came down and shoved meaning in your face, you wouldn't be convinced because there's no way for your mind to be changed. I get what you're saying. It just feels like asking whether life has meaning is a meaningful question, you know? Like, it feels like there should be an answer. There might be one. But surely until we can properly understand what we mean by the question, we can't really be certain either way. Thank you for agreeing to do this interview.
The pleasure's all mine.
Yeah, it's so great to be finally talking with a hedonist. Or is it hedonist?
It's whatever you like.
Cool. So, as I understand it, you hold pleasure to be the highest good.
I do indeed.
So if that's true, why would you do anything except take drugs or have sex?
Oh, please. You don't honestly think that our conception of pleasure is that unsophisticated, do you? Physical pleasure is a bit like sugar. Yes, anyone can appreciate some simple sweetness, but too much of it leaves a sour taste in the mouth. A refined palate develops a taste for much finer pleasures, like that of friendship, or knowledge, or power.
I see, and obviously a drug addiction would cause a lot of corresponding pain.
Correct, but again, there's nuance. Certain kinds of pain can be very pleasurable. They aren't simple opposites, they're complex.
So some people think that ultimately everyone acts in their own self-interest, that even when someone is acting selflessly, they're really doing it to make themselves feel better. What do you think about that?
Ah, yes. Well, that's the theory of psychological hedonism. That doesn't really interest me too much. I'm more of an ethical hedonist.
But do you think it's true?
To some extent, I'm sure it's true, that everyone acts in their own self-interest.
And perhaps some people act selflessly not to feel good, but to avoid the pain of a guilty conscience. So, what is ethical hedonism then? Is it just, it's morally good if it feels good? Well, it has many forms. I take most of my inspiration from Aristippus, and some from Epicurus. The best life is the one with the most enduring pleasure, but you need some moderation to achieve that. You can't party hard every day, but not partying at all is also no good. We strive for balance. But isn't that a bit selfish and shallow? Like, what about meaning? Selfish? Shallow? My friend, some of the best pleasures in life are mutual. Are we not here to enjoy each other's company? A good life is surely a fun one that's fun for others too, right? I think there's plenty of meaning in that. Interesting. Besides, this isn't too many steps away from the ethical theory of utilitarianism, which is all about maximizing the common good, which, if you ask me, is a much less sexy branding.